Okay, good afternoon, good morning, good evening, good night, depending on when you're watching this video. In this video, we are going to work through the examples of working with the F tables that are given on slide 33 of lecture set 10. So F distributions are right skewed distributions, like a chi-square distribution. And unlike a chi-square distribution and a t distribution, F tables use 2 degrees of freedom, which we commonly can call df1 and df2. Sometimes they're called df numerator, df denominator. There's a variety of different referring terms, but the way that we work with these values is the same. Okay, in the first two examples, we're going to look at demonstrations of what would be finding a critical value for a F-based hypothesis test. And then exercises 3 and 4, we will look at finding p-values or examples of finding p-values for F-based hypothesis tests. Okay, so the starting point for all of these problems will be the same. We're going to sketch out a right skewed curve, very much like we did in the case of a chi-square distribution. I'm just going to make this a little more skewed. Really want to emphasize that skewness, right? And what we are doing with F tests is we are working in the skewed tail. So there's no concept of two-sided testing with F tests. It's always going to be tests conducted in the skewed tail. So here we have an F value on 3 degrees of freedom, 6 degree of freedom, and 0.05. So the 3 is going to be df1, the 6 is going to be df2, and then our significance level would be 0.05. Okay, so what we have to do is start to comb through the F tables now. So you'll see that the F table is labeled dfn, so df numerator. Okay, so this would be df1, and the dfd, which is df denominator, would be df2. So we have 3 in the first slot, we have 6 in the second slot, and then we have 0.05. So that gives us a value of 4.76. So if this was a hypothesis test, we would have an F value on 3 degree of freedom, 6 degree of freedom, and the 5% significance level. So the critical value would be 4.76. Okay, so this value here is 4.76. Okay, exercise 2. It's the same starting point. Okay, so we have our F curve, right? Oh, and then we have F on 8, 3, 0.01. All right, so we go back to our table. Now what we're trying to do is match 8 in the first slot. Okay, so we have 8 degree of freedom. Match that to 3, 0.01. We scroll across, and that gives us 27.49. Okay, so for the second example, this would be the case where you have 8 degree of freedom in the first spot, 3 degree of freedom in the second spot, and then a significance level of 0.01. So that gives us 27.49. All right. In the third illustration, our starting point is the same, but now what we are doing is we are marking down the value that's given in the probability statement. So we want to say, or what we want to find, if this F value is 10.62, we want to know how large is this green shaded area here. So we want to know the value or the size of this green shaded area here. All right, so what we would do is we would take our degrees of freedom, so 3 and 6. We would go back to our F table. Okay, so we have 3 degrees of freedom here. We have 6 degrees of freedom here. Okay, now you can see that what's happening with F tables is you work vertically rather than horizontally. So we are going to take our test statistic value, which is what this would represent, which is 10.62. And we are trying to figure out, or we're trying to determine, where does the 10.62 fit in between the 5 values that are given at 3 and 6 degrees of freedom. Okay, so 10.62 is bigger than 3.29. 10.62 is bigger than 4.76. 10.62 is bigger than 6.60. 10.72 is bigger than 9.78, but smaller than 12.92. So we are in between these two quantities here. Okay, so our value 10.62 is in between 9.78 and 12.92, which means that our tail area is in between 0.01 and 0.005. So what we would write is 0.005 is less than the probability that f exceeds 10.62 is less than 0.01. And that would be the solution to this problem. Now, if this was a p-value problem, we would just have a few additional lines, like we would say p-value equals the probability that f is greater than 10.62. Then we would say since 0.005 is less than the probability that f is greater than 10.62 is less than 0.01, then 0.005 is less than the p-value is less than 0.01. But this is still an illustration of how we would use the f table to find a p-value. Okay. Okay, and then in the last example, it's the same style of problem. So the starting point here, we sketch out our f curve. Now our test statistic value is 4.5, and we're at 6 and 8 degrees of freedom. Okay, so we would just mark down f equals 4.5. Just like in the previous problem, we want to find this area here. With f tables, the illustrations will always be the same. We're always working in the skewed tail, so we'd always have the same style of setup. Our degree of freedom are 6 and 8 in this case. So we go back to that first page of the f table. We're going to match 6 degrees of freedom to 8 degrees of freedom. Okay, so 6, 1, 2, 3, 4, 5, 6. So we're in this slot here, this area here. Our test statistic is 4.5. You can see that 4.5 sits in between 3.58 and 4.65. So that means that our area of interest is in between 0.025 and 0.05. So here we would say 0.025 is less than the probability is less than 0.05. Okay. So the general strategy is very similar to a t-table probability, or is very similar to how we find probabilities with the t-table and the chi-square table. It's just the organization of the f-table is different because you first have to match the 2 degree of freedom, and then you're working in those little sets of critical values now, rather than across the table. All right, as always, if you have any questions, please let me know.